right, thanks everyone for coming. This is going to be the lab on how to detect, drift, and enforce OPA policies in Terraform Cloud. As Jasmine introduced us, I'm Rita. This is Robin, and we're going to be leading the discussion today. But we also have a few TAs in the room. If my clicker would work, it's not happening. Okay, there we go. So with us, we also have Mike Augustine, Simon Davis, and Paul Thrasher, who will be helping field any questions about the features that we talk about today. I'll pause at certain moments of the lab just to prompt for questions, so hold on to them until those moments, because we've got a few longer running Terraform applies that we're expecting. And as a reminder, we're going to abide by the code of conduct here today, so just to make sure that everyone has a pleasant and safe experience at HashiConf. If you see anything to the contrary, please get in touch. You can find the code of conduct on the website. Let me check the clicker. Okay, we're working now. Thanks, Robin. Yeah. Cool. So today I'm going to be talking to you about a few different automated validation and enforcement mechanisms. What are these and why do we use them? So when you're first getting started with infrastructure provisioning, you might be a smaller team and it's easier to have oversight over all the resources that you're pushing out. So it might be fair to expect that your engineers are reviewing your PRs thoroughly, keeping whatever set of standards in mind, and applying those in their reviews. But as your organization grows and matures, it gets harder to enforce that and it becomes brittle. So you probably have many more resources, many more engineers, many more standards, and it's likely that there might be some operator error oversight. So the value of automated validation and enforcement mechanisms is that you don't have to worry about a human applying and enforcing them. You write them as code and you can trust that they'll be applied consistently within your environments. So the first type that I'll be talking about today is configuration level validation. There are a few that are available to you if you're managing infrastructure with Terraform and Terraform Cloud. Variable validation, which we've had for a while, is at the variable input. So you can write a conditional expression, check whether that variable input satisfies it, and then Terraform will evaluate it for you. Today I'll be focusing on pre and post conditions, which we introduced in 1.2. So these are resource level configurations that you configure within the lifecycle block of your resource definition. And I'll go over in just a moment how those are evaluated. So as I mentioned, you're going to include those pre and post conditions within that lifecycle block. You'll see an example in just a bit. With the precondition, you write it into your configuration, run a Terraform apply. Terraform will evaluate the condition, and if it passes, it'll create your resource. This is good for any values that you know ahead of time, so you're just verifying that the inputs are what you expect them to be. Post conditions happen later in that process, so you write your conditions within your resource definition, run your apply, and this is good for generated values. So maybe these are tags that are computed on the instance, which VPC the instance is going to be dropped into. Anything that you don't know ahead of time, this is a good way for you to verify your assumptions that the infrastructure is configured as you expect it to be. So these are good for enforcing standards within your modules. If you have modules within your organization and you want to enforce how downstream consumers interact with them, these ensure that any of those conditions will be satisfied before someone else tries to deploy that infrastructure. So there is a bit of a contract. You expect your module authors to include these definitions within the configuration, and you also need your developers to use those modules to ensure that those restrictions are in place. Policy as code gives you a broader umbrella of coverage. So rather than expecting configuration to be written in a specific way, you can trust that you have oversight regardless of who wrote the configuration and how. As you heard at the keynote, we now have native support for OPA within Terraform Cloud. We also have the option of Sentinel. We'll be focusing on OPA today. So, did I skip one? Yeah. Okay, what is OPA? If you're not familiar, though I'm sure you all are, it's Open Policy Agent, which is policy as code. And this decouples your policies from the actual infrastructure. We initially supported this with just run tasks with our Styra integration, and now we also have support natively within Terraform Cloud. So the way that this works is after you define a policy set within your organization and associate it with a workspace, Terraform Cloud will run those evaluations on any workspaces that you've attached that policy to. So After you run your plan, Terraform Cloud will take the JSON formatted plan output, run it through the agent, check any policy sets that you have configured on that workspace, and then decide what to let you do or not. I'll go over the enforcement levels in a little bit more detail later, but there are two available, advisory and mandatory. An advisory basically just lets the user know that there may have been a failure, but that there was a failure, but will allow them to create their configuration anyway. Mandatory will hard fail unless you configure an override, which I'll walk you through in just a little bit. So how do these all work together? I'm going to work from the inside out, but where the different validation mechanisms are placed is intended to designate the maximum scope of coverage that you can configure. So starting from pre and post conditions, as I mentioned, those are within the module. So if your module authors include them in the configuration, you can trust that those will be enforced anytime the user uses the module with that definition. A run task is applied per workspace. So if you have a run task that's checking for any sort of conditions associated with the workspace, and it'll execute there. More broadly across your entire organization are policy sets. You can still scope those to specific workspaces, but if you just want broad coverage and peace of mind that your policies are being enforced, a policy set is a good way to go. So everything I talked about just now was at apply time. You run your Terraform apply, it checks that your conditions are satisfied, any run tasks pass, any of your policy sets succeed as well. Later on in the life cycle, health assessments come into play. So as you heard this morning at the keynote with Armand, this gives you coverage throughout the infrastructure lifecycle. So rather than just checking at the time of your Terraform run, we're now also validating whether there's been drift in your workspace and if any of the conditions that you violated have failed continuous validation over that lifecycle. Health assessments are available in the business tier, and you can enable them on a workspace or across the entire organization. So today I'm going to be walking you through how all of these interact, but it's important to note that I'm taking over the 3 different personas. So first we have the operators. These are the users that are running Terraform apply, the module users. We also have the security team. Those are going to be the people who are defining your OPA policies and guidelines. And then the platform team, that's a different persona. Those are likely the module authors and the ones enforcing drift detection within your organization and workspaces. So the scenario I'll walk you through configures all those different compliance guardrails. First, I'm going to show you how to use a precondition to, as we discussed, establish a guarantee on how someone uses a module, specifically to not over-provision a bastion host. Then I'm going to use OPA policies to both prevent overly permissive security groups and block Friday deploys to give you all a peaceful weekend. And then we're going to use drift detection to identify infrastructure divergence. So maybe someone worked around the policies. We're going to see how drift detection catches that. I'm going to be kind of flying through a tutorial that's available on the website. You can follow along with it here, but you could also run it on your own time a little bit later. And we'll be at the booth if you have any questions about what I go over today. I'll leave it at that. Let's get started. Where do I set that? Cool. So if you follow along with the tutorial, it'll prompt you to fork an example repository that contains the configuration that I'm working with today. So let me just fly through what is configured in here. Similarly to how I'm assuming 3 different personas today, all of my config lives in one repo. Not a good practice in production. This is just for ease for the sake of the tutorial. So to start, I'm using a local module, pretty simple root level configuration, but I'm instantiating it with one input value. And let's take a look at what that module actually configures. So as I mentioned earlier, this is going to be a networking resources module that configures a bastion host. This establishes a contract for any users in your organization that if they're provisioning networks, the ingress SSH traffic to those hosts should be going through that bastion. So to do that, I'm using the public VPC module to configure the networking plumbing. That's my VPC, subnets, NAT, and internet gateways. Then I'll jump back to the security group in a moment, but within that network, I'm provisioning my EC2 Bastion instance. Also pretty lightweight configuration just for the sake of the demo, but I'm plugging in my Bastion instance type and AMI using those subnets and a security group that I'm defining here. And that security group is scoping any SSH traffic to just a hypothetical internal CIDR block that might represent like your internal VPN. So the intention again here is to scope the traffic to my private networks by also reducing the entry point in the Bastion host to just my internal VPN. So as I mentioned earlier, there's an input available here for the Bastion instance type, but if the Bastion is only taking SSH traffic, it doesn't make sense to over-provision that host with too many resources. This is a good candidate for a precondition. So what you could do, what I will do, is show you how to define one. So first, I'm gonna define a data source that pulls in that input variable and checks for the details of that instance type from AWS. So based on whatever instance type it passes in, this data source will capture if EBS encryption is supported, how many cores are configured within that instance type, a lot of great details. Then I'll define my precondition. So as I mentioned earlier, this is, let me just clean everything up. This is within the lifecycle block of your configuration. So what this is doing is checking whether that data source tells me that I have 2 or fewer cores. And if I fail the condition, it's gonna issue a helpful error message to the user for how to correct it. So just for the sake of demonstration, I'm initially using a T2 2x large, which I know will fail. Let's see what happens. So going to run a Terraform init. And then a Terraform apply. I didn't mention, but maybe it was implied, I'm using Terraform Cloud for operations for this. So init created my workspace for me, and that's where all this good stuff is going to happen. So waiting for the run, we can jump over to the workspace just to see what's going on. I see that my run was triggered via the CLI, and I expect that to fail. Sorry, my monitor keeps cutting out, so checking that I see it here. Yep. So as expected, the precondition failed. And I have that output telling me that it's because I have 8 cores in that instance type, and I'm telling the user exactly how to fix that. So let me jump over, correct the instance type, and run another apply. Now, while this is running, I want to point out that you could also do this for variable validation, but the precondition lets your configuration be a little bit more dynamic. If I took the variable validation route here, I would need to list out all the supported instance types within my variable definition. This means that if AWS introduces a new instance type that I didn't capture, my precondition might get skirted around. It also means that your configuration has a lot of noise. So by using the precondition and relying on that data source, you allow your configuration to be much more dynamic. It pulls in the latest information based on that input variable from AWS and checks the condition for you. So that's how those two can play together. You can accomplish a similar task, but one of them gives you a little bit more flexibility in your workspaces. So I'm going to run that apply, and we'll have a few moments here if we have any questions yet. Anyone? Cool. So one of the questions that often comes up with pre and post conditions is what happens if they fail? So it depends on when it's evaluated and whether the resource will be created, but the run will tap out after that failure, and the operator will have to go in, correct the issue, and run another apply. So there is still a manual element here in that you have to understand the nuances of your infrastructure and correct that configuration accordingly. Waiting for it to run. Robin, anything I can clarify on while we're waiting? Yeah, so the question was where do the 8 cores come into play? Because I plugged in the T2 large value into my variables, my configuration pulled the details of the T2 large type from AWS, and those details are within that data source. So it's just passed back from the provider.
Maybe you could pull up the configuration that shows the data source while it's running.
Good call. So, no, it's in the module. Yeah, so it's relying on this data source. So that T2 large is what's referenced with that Bastion instance type variable, and then it'll just pull that information from there. Does that clarify? Nice, thank you. Let's see if our run's complete. We're still going. Okay, so I think I'll jump, oh, yes. So Terraform will evaluate it wherever you're running the condition. It's for continuous validation that you need that constantly running environment for it to continue evaluating the condition throughout the life cycle of your infrastructure. Yeah?
What will happen with the resource if post condition fails?
If the post condition fails.
You said it's after the resource is created, the post condition is evaluated. What will happen with the resource which is already created if it fails?
Okay, so in the case of the post condition, that's evaluated on the generated values. So I believe Paul, is this right? It'll tap out and you'll have to go in and correct that condition, but the resource won't be rolled back, right? Yeah. Yeah, so whatever resource failed it exists, but the rest of the run won't complete if anything is dependent on that, if that makes sense.
But will the resource be tainted and recreated at the next run, or will it still stay around?
If you don't correct the configuration, it'll just keep failing the same way. So if you want your run to succeed, you'll need to modify the configuration. And if Terraform has to recreate it, it'll recreate it. If it can update it in place to satisfy the condition, then that's what it'll do as well.
Okay, thank you.
You're welcome.
And just to jump in and clarify, the error that we're showing in this lab is during the plan step.
Yeah.
So it's not actually creating resources, but it is possible, as you were asking, for the failure to occur during the apply step. And resources could be created there.
Yeah, that's right. Thank you. Yeah, so Terraform will evaluate the condition as soon as it can. In this case, because it's dependent on the data source, it could even do that at plan time. So you run a Terraform plan, it'll pull the details from the AWS provider, and it won't go on beyond that. So yeah, we evaluate it as soon as possible. In the meantime, my resource is finally created. So as I mentioned, using pre and post conditions requires a contract for your module users and consumers. We're going to now look at how policies gives you a broader scope of coverage. So, as I mentioned, I have my OPA policies defined within the same repository, which in a production scenario, they likely live separately. But let's review what they are. The first is a public ingress rule. So since my configuration is trying to lock down network traffic within my VPC, it also makes sense to check that there aren't any overly permissive security groups being provisioned. This is just one example of a rule. You probably want much more coverage. But the way that the policy is defined, up at the top, I have my package definition here. You can call this whatever you like. Then I have a declaration for the Terraform input, and this will be in JSON format. I'm setting that as TF plan to reference throughout the policy definition. And then I have my rule, which I've called deny. What this will do is it'll look through the resource changes in that plan input and look for anything for the AWS security group resource type. If the changes within the plan show that the CIDR block within the configuration after the run will include that zeroed out CIDR, then it'll add a message to the list of policy failures, and Terraform Cloud will return that. So I think it could help to take a look at the format of the Terraform plan as you develop these policies. But this is just how this rule is stepping through. The other example, as I foreshadowed, is this No Friday deploy policy. So I think this shows you that you can use policies for both your infrastructure configuration and your organizational standards. You probably don't want engineers deploying breaking changes on Friday afternoons and stressing out whoever is on call. So this is a good approach, good idea. So again, I have my package definition up at the top. This time I'm not relying on the Terraform input at all. It's just a matter of the timestamp. So I've defined my rule. I'm checking whether the current day is a Friday. And if it is, I have the message, no deployments allowed on Fridays. It's not Friday yet, So let me change this to, it is Thursday? Cool. Let me change this to Thursday just to show you how this will work. So the thing that I didn't mention yet is that I'm using VCS to manage my policy sets. There are 3 options available within Terraform Cloud. You can either use the API, you go through the UI and click around, or you can use VCS and have your repository be the source of truth. And I'll show you a little bit of the UI for it if you're managing it manually. But in the meanwhile, let me just push up my change to my repository. So add the OPA directory, update OPA policy, and push. Cool. So taking a look at the, I missed one part before we jump over to the UI. So I have the policy definitions themselves, but I also need this top level policies HCL file. And this has to be called either policies HCL or policies.json. You could take a look at the docs for any other requirements for configuring your policy set through VCS. But it captures the 2 policies that I want in this policy set. The first is that Friday deploy. And it's referencing a query that is a construction of the package name and the name of the rule that I'm evaluating within that configuration. So just for a side-by-side look, let me close that out if y'all can see. So here I have the query as data.terraform.policies.fridaydeploys.deny. So that data is standard within this policy definition file. The next part relies on this package name and then the rule on line 3. So that's how you construct that value. Now, again, you can call these whatever you'd like. You just have to make sure you reference the correct query within your policy set definition itself. Alongside the query, I also have the enforcement level, and I'll go over this in a little more detail when we jump to the UI. But for these 2 policies, I'm setting a mandatory enforcement mode, which means if there's a failure, users should not be able to provision any infrastructure that violates the policy. So going to the UI, policy sets are still an organization level resource, so you'll find them in Terraform Cloud under your organization settings, under policy sets. And I'm going to connect a new one. So I'm going to select my VCS provider, my user, my forked repository, and then configure the specifics of the policy set itself. So I'm using OPA as a policy framework. I'm going to keep the name as is. This is based on the repository name. Then under policy set source, I'm going to set the path. So as you noticed, my OPA policies are in a separate directory within this repository, and I want to make sure that that's where Terraform Cloud evaluates the policies from. So set OPA as the policy path. I'm using my default branch. And now we're down to scope. So I can set policies enforced on selected workspaces, and I'll choose them down below. Now here's that override option. This is a policy set level setting. So if I have this enabled, it means that with a mandatory failure, any users with a manage overrides permission on their Terraform Cloud account or team will be able to override that failure. So that could be good if you have some engineers on the team who you want to have that access in the event of a policy failure. I'm going to uncheck it. The other thing that I didn't mention, if you are Sentinel users, you may be familiar with the fact that we have 3 enforcement method levels within Sentinel. We have advisory, soft mandatory, and hard mandatory. With OPA, there are just 2. It's just that advisory and mandatory with the option to override for users with the permission if you check that off. So let me associate this with my workspace. Click enable. Cool. So that's how you configure the policy set. If you wanted to configure it through the UI, then you would go to the policies page, click create a new policy, and a lot of similar input. So what's the policy framework? Give the policy a name, the enforcement mode, the query, which is that construction of the package name and the rule, and then the policy code itself. And you can also immediately attach it to a policy set if they already exist. Cool, so I've attached my policy set to my workspace. Let me go back to that so we can follow along. And we can see it in action. So let's assume or imagine that there's a production incident and an engineer wants to override that scoped down security group. They can't get on internal VPN. They need access to the bastion. What they may do, what we all maybe have done once or twice but should admit to, was open up the security group. And at least they're trying to do it through the Terraform workflow. So let's see what happens. I'm going to run Terraform apply. And expect that policy to fail. For those of you who are going to try this out in beta, I'll call out that the CLI output is a little bit misleading right now. We'll implement CLI support for the policy results in time for GA. I'll show you how that looks like so you're not surprised if you do give it a try, but then we'll take a look at the actual UI for how this works. Cool, so I have my expected change. I'm going to grab the security group ID because I'll need that later. And wait to see what happens. Any questions? Yeah.
I'm not sure you showed this later in the talk, but how does testing work with OPA? In Sentinel, we have Sentinel test. We can use mock files. Well, OPA, what's the equivalent there?
Yeah, I would say the Rego Playground is probably a good place to start. So you can get the example output for a run from Terraform Cloud with the mocks, and then plug that into the Rego Playground and iterate on your policies there.
Okay, thanks.
Cool, we'll have a little more time for questions too. So jumping over to the UI, yeah, as I said, misleading result, we're gonna work on that. But in the UI, the run failed as we expected. And if we go into the details, we see that their OPA policies failed. This is now a new field within the run. And then if we expand it, we see the 2 policies that we configured. So deployments on Fridays are blocked, and the security group was overly permissive. Cool. So in the next section, I'm going to be showing you how drift detection, feeling a little bit lightheaded. Robin, do you mind jumping in? Cool.
Got it? Okay. Okay. Okay, I'm just going to jump in and take over. Rita's not feeling so great. So just to cover what we, to review what we just saw, now we're triggering OPA policies that we defined in VCS, and those will trigger on any configured workspace. So let's go ahead and fix the policy issues. And I'm sorry, I don't know exactly how Rita's computer is configured. Do you have VS Code? I'm sorry, I'm not a Vim guy. No? Okay, that's fine. Nah, I got it. Okay, Vim, OPA, policies. And I'm just gonna be baby talking our Vim here. Oh, it's already open in another thing. Edit anyway, and we'll just overwrite. So I'm going to change this back to Friday. Oh. Okay, I remember a little bit of Vim. Not Friday, Friday. All right, and we also need to change the module configuration as well. Whoops, not that way. Yep, see? Kill that line. Nope. Anybody want to do some Vim tech support for me? Thank you. That was it. And then, how do I paste that? Oh, and I did it in the wrong place. I got it. Thanks for the Vim help. Okay, so I fixed that, and then we're going to change this back to an allowed CIDR block just to move forward. Close enough. Okay. And now that we've fixed, so backing up and giving a little bit of context, we've had two policy violations, and I'm fixing them in two different ways. So I just want to cover that. The security group I'm fixing by putting the security group back into compliance with the policy. The Friday deploys, since we can't change the day without waiting around for a little while, I changed that back to actual Friday to allow us to deploy on Thursday. So I need to, that's why I shouldn't have applied yet. What I need to do is I need to push those changes to Terraform Cloud, the policy change for OPA to pick that up. So let me, I've gotten off track there a little bit. So let me cancel that plan. It might just take a moment and we'll get right back on track. Do we have any questions while I'm waiting for that to fix itself about OPA policies or anything we've talked about yet? All right, and we still have the screen there? Okay. So we're going to update OPA policy and security group. Config. Okay, and let me push that. And now that I pushed that policy change, Terraform Cloud will pick that up. The other change we're making is to update the security group. So I think we should be back on track now. All right. While that's running, do we have any other questions? All right, so just to recap while this plan is finishing, we had, and that's actually going to change the config because I got the CIDR block wrong. Ordinarily, we would just be updating we would be applying to verify that we were in compliance with the policy. We wouldn't actually be changing any resources. I'm gonna go ahead and leave that as is so we don't mess that up, but we should have a plan here. There we go. And I'll go ahead and apply that change while we move on. Okay, so if that has an error, then we'll talk about it, but it shouldn't. So we've talked about two different ways to make sure that that your resources are deployed correctly. We looked at pre and post conditions, which are something that you as a module author will add to your modules or Terraform configuration to make sure that people are using them correctly. The OPA integration, as well as Sentinel and Styra integration through run tasks, are more about enforcing policies for your entire organization, more of an enforcement mechanism than guardrails that pre and post conditions apply. In either case, both of these tools are looking at the beginning of your resource lifecycle. They're about preventing us from applying changes that are incorrect. We also want to look at our resources after they've been provisioned, so later on in the lifecycle. And that's what health checks are all about. So let's go into our workspace overview. And over here, we've got a little section that tells us about health checks and lets me enable them for our workspace. You can also enable health checks across your organization, in which case they'll run on all of your workspaces. Enabling health checks means that periodically Terraform Cloud will reach out and check to make sure that your infrastructure is configured correctly. And it does that in two ways. First, drift detection, which we'll be looking at in this lab, will essentially run a Terraform plan and compare the state of your resources reported by the upstream API with what you configured. So, for example, again, we're trying to troubleshoot this hypothetical issue, and we want to be able to SSH to the Bastion host. So the policy prevented me from doing that earlier. I want to go in. I want to go into the AWS console and make that change manually. For some reason, somebody gave me permission to do that. So let's see if we can violate some company policies. And I think you put that in your, thank you very much, Rita, in your clipboard, so I can find the right security group in here. And oh, I need to click on the security group. There we go. I know how to use this thing. And I'm going to edit the inbound rules. So again, this is essentially the same thing that we were looking at in our Terraform configuration, where we configured your security group ingress rule to only allow SSH connections to this subnet, to this CIDR block. And I'm going to go ahead and open that up to the world. Now, that's not going to trigger a policy violation because we're not doing it through Terraform. But what it will trigger is our health checks will notice it. I'll go ahead and enable that. So after I've enabled it, it will run in the next 5 minutes or so. So hopefully we'll be able to see it here today. It will also run about every 24 hours thereafter. And you might hear the word about in there and wonder what's up with that. Essentially, we don't want them all to run at 8 a.m. or 9 a.m. So Terraform Cloud is doing a little bit of scheduling for us to make sure that it's not doing it for all of our workspaces at once. And things like that, and making sure that if you do a successful apply, it resets the timer, so it'll run in about 24 hours. So again, if our live demo is working correctly, we'll see that health check come up there. Otherwise, I'll run away, I guess. I don't know what you do if live demos don't work. But it should be there in a moment. While we're waiting on that, do we have any questions from the audience? I see some microphones coming around. If you want to raise your hand, go ahead.
Hi, just a quick question. How should I think about the pre-task condition versus the kind of OPA policies? Which ones do I use for what? Because they seem like they do the same thing.
Yeah, there is a little bit of overlap in what they can do. Let me run back to this diagram. One more. I think about it in two different ways. It's who's writing the policy and whether it's an enforcement mechanism or whether you're just helping people use your configuration correctly. So the pre and post conditions that we showed at the beginning, those are written by whoever's writing your Terraform code. They're also living inside your Terraform configuration. So it's not really an enforcement mechanism if I can just go and remove that post condition, or if I can just provision my own darn Bastion host and security group and not use the ones that the module author wrote. So again, more about helping. For run tasks, those run per workspace after a Terraform plan, within Terraform Cloud, and that's kind of a more generic integration. You can go and check some external tool. And then the Sentinel and OPA policies that we're supporting natively within Terraform Cloud, those are also more of an enforcement mechanism. You're probably going to have some other team, like a security team, writing those and going through and checking to make sure you don't, often security things, you don't want to open up a security group. You might also check to make sure that database passwords are being configured correctly or things like that. Did that answer the question?
Yes.
Okay. And I'm sorry, I know you're back there, I can't see you. So, did we have another question?
Yeah, so in regards to some of the static analysis tools like Checkoff and I don't know, some of the other ones, like are the policies meant to complement tools like that or replace?
Yeah, I would. I'm not familiar with Chekhov, honestly, but in this case, it's, I believe, a complementary mechanism. OPA is about the policy enforcement. I don't know if there's a better answer for that. Go ahead.
Okay. Hi again. I'll clarify that run tasks, Sentinel policy sets, and OPA, they can all exist within the same workspace and get applied to the same run. So they're likely giving you different types of coverage on whatever's happening with your infrastructure. So yeah, you can just incorporate them all together. I guess there would be a little bit of redundancy if you're using both Sentinel and OPA on those policies, but if you have some Sentinel policy sets and you're moving toward adopting OPA, that might be why you have all three. But does that kind of answer the question? Different areas of coverage, you can use them all together. Just depends what they need to enforce. Cool. Okay. Thanks.
And I don't see any more questions, but I'll give another opportunity for questions in just a moment. Before we do that, I want to say that, hey, the live demo did work, which makes me happy. Hopefully you're happy as well. Here in the workspace, we can see that the health check ran and look at the details of it. All right, and we're going to be able to dive in and see that, hey, what we have configured is this, and what is actually present is this. So I want to talk about a couple of things here. First off, because I got a little off track from the demo we're doing, ordinarily, I would have shown that there were a couple of false positives at this point, because, as you may know, sometimes the cloud provider or the upstream cloud platform will set things that you don't set through configuration, default values and things like that. So on that first run, you may see some extra things that have drifted even though they haven't drifted. The other thing to think about here is what we're going to do about the drift. And that's something that really an operator needs to make a decision about. So Terraform Cloud isn't going to automatically do it. And so if we like these changes, maybe we'll go ahead and update our configuration to reflect them and then run a refresh only plan. Otherwise, we really didn't want somebody to go and muck about and make this manual change because we're Terraform people. We want to do everything through Terraform. So we'll queue another plan to overwrite that change and return to the security group configuration we had earlier. So that should cover it for drift detection. And go ahead and if we do have any other questions, let's go ahead. I think we've got a couple more minutes before they kick us out.
Do you have auto remediation when you have drift detection? That, for example, if a drift is detected, it will automatically apply a new plan, create a new plan to fix it?
No, it won't automatically apply that right now because we or Terraform Cloud doesn't know whether the drift is maybe you introduced the drift when you went in and troubleshot when you fixed a problem that you want to preserve that change, or maybe somebody changed something that you don't want to preserve. So somebody needs to make a decision there. If you have use cases where automation might be good there, feel free to drop a note to our team or come by our booth and we could talk about those. I think the team would be interested in those use cases as they continue to work on the feature.
It's like to avoid that people change things in Portal because they shouldn't.
Yeah. If we can prevent that, then that would be great. But don't give me access to prod. That's one suggestion I will give you. Go ahead.
Hi. Is there a way to send notifications so like when it detects?
Yeah. So you can trigger a notification through. You can set up a webhook through. Something like a Slack notification, and so you'll get on whatever Slack channel. We don't have that demoed out today, but that's I think instructions for that are in the docs. I think we've got more questions over there.
Yeah. Is the drift detection you showed using the same APIs as the previous drift detection that was like present? I think it's the assessment APIs. Is that on the same APIs there?
Yes, I honestly haven't looked at the actual API structure, but it's all part of the health checks part of the API. Again, I point you to the docs for exactly, but I believe it's all under the same
Got it. So
APIs.
not a change to the API, it's just it's using the same
I don't want to say they might have changed it. I honestly didn't look at the APIs, so it might be slightly different, but I think it's in the same place.
Okay, thanks.
Hi. For the drift detection, every time it runs the drift detection, is it actually cloning the repo every time, or does it have a local copy of it? And like, what commit ID is it trying to check against every time?
Oh, that's a good question. I do not know under the hood what Terraform Cloud is doing there. Do any of our guys have a...
It uses the last run. But it'll actually actively clone it from the repo? Or whatever is in there in configuration. Okay, so actually we'll make a call to our repo repository. Not anymore. Yeah, not anymore. But we'll get that specific commit ID from the last run, basically.
What's already there in Terraform Cloud?
Okay, okay.
Terraform Cloud retains the last run, so that it already has extract the code and now
Okay.
and all that. So it's actually running against that last run.
Okay.
And just because not everybody was on microphone, I'm going to try to recapitulate that. But I think the question was about whether Terraform Cloud is going to go and clone your repo again and rerun everything. And I think what y'all are saying is that it already has everything and is just reusing the last one when it verifies. Okay. We've got some more questions, I think.
Any plans for this to be available on Terraform Enterprise?
I'm sorry, which one?
For like all these to be available on Terraform Enterprise?
So not yet for, I believe, OPA and drift detection. Is that right? Neither of them. And then the pre and post conditions are those are part of Terraform open source. So those are available in Terraform Enterprise, but not the other two.
Do you know?
Oh, go ahead.
So I was saying that it is coming to Terraform Enterprise, both features, but the dates have not been announced specifically, but it will be coming in the next few months.
Yeah, thanks. So I have a question. So in our case, we might need to make the OPA policies available for multiple workspaces and all. So is that something that we can enable something kind of like a module or something like that so that the teams can just somehow pull those policies in order to validate? Because in this case, we were doing on the specific repo, right? But I wanted them to pull it from a central repository. Like in this case, OPA does have something like the bundle registry. So I was wondering if that's something that it would be supported in Terraform Cloud, or how would it work?
Yeah, so there's, let me see if I can go back to the Terraform Cloud UI to talk a little bit about that. Not workspaces. So there's a few different options there. So let me, correct me if I don't answer your question fully, but when we define a policy set, let's say you have several policy sets in one Git repo. Each one you could create a new policy set for, and just as we did here where we set the path, you could set them that way and have one policy set. But then you were also asking about applying them to more than one workspace. So here, when I create or update the policy set, I can just blanket and put them on all workspaces, or set them on specific workspaces. Now, as far as who gets to assign policies to workspaces, that's a permission within Terraform Cloud where you administer that. That would be, I don't think there's a mechanism right now for me as someone who doesn't have that permission to just subscribe to an existing policy set. It's kind of inverted where it's the admins are deciding which workspaces. Is that correct? Sound pretty good? Okay. Did that answer your question?
Yeah.
Okay, great. Thank you. Any other questions? I think we're over time. I don't know if they're going to kick us out right away or not. But
just one quick on the registry now we can have policy libraries shared. Can we share OPA policy libraries or only Sentinels?
I'm sorry, I didn't quite hear your question. It was about sharing OPA policy.
So on the registry, we can now have the policy libraries. We can share them. Is it only Sentinel, or can we also share OPA policy there?
It's only Sentinel right now. I don't know if there's any features in the works for that, but right now it's only Sentinel.
I will say a lot of what we've been showing you today is beta or very new features, so we want that feedback. Talk to us at the booths, open up a Git issue. The teams really want to know what dials you want available to you, so we don't know what's in the works yet, but it could happen.
Okay. Any other questions before they kick us out? Time, okay. Thank you so much for coming, and thanks for